Hello, everyone. I'm so happy to be here. Sorry for the short brief. I had to run 30 minutes, public transport. So, as I said, I'm really happy to be here. Thank you for coming. Together, we will discuss about reactivity inside a modern framework. Just wanted to know who here is a front-end developer? Okay. Oh, there are people that are not front-end developers. That's really interesting. Who's a React developer? Okay. Angular. A lot of Angular. Vue. Solid. Svelte. Okay. That will be interesting. Which one is the best? Let's go for the fight. I'm Sylvain. I work in the Criteo R&D. I'm part of the team named the UI Foundation. We are the team that implement and maintain the design system library. So basically the Angular material of Criteo. We also are in charge of what we call the generic shell. This is the shell that every front-end app can take to integrate into micro front-end, because we work with platform using micro front-end. So we in charge of that. And also, since in the team we are front-end developer experienced, we also help time to time the other teams by going to their teams for like a week to a month. That's what we call a voyager or nomad. So the history behind this talk started a few years ago on my Twitter feeds. I saw tweets like this one. So Rich Harris is the one that created Svelte. And he was mentioning about something about reactivity, like framework that struggle to solve reactivity. And he said that React re-render the world. Apparently, Vue, they wrap into data accessor. So Svelte defeats TypeScript some way and somehow, and like provide imperative setter. And Angular, we don't know how it works. So I saw this, and after that, I saw Evan Yu, so the creator of Vue, that responded. But with Svelte, you're cheating. We can call it basically Svelte script because it's no longer JavaScript or TypeScript. And Ryan, the father of Solid, that said React isn't reactive at all, and but it's not an issue. You shouldn't care. So seeing at all those tweets, I was like this little penguin, like what the hell they are talking about. And I mean, maybe on LinkedIn you saw people fighting each other to get which one is the better between React and Angular. But here, those are true experts talking about something meaningful behind the scenes. So I wanted to understand that. And when I struggle to understand something that I really care about, my goal is like to understand it and then create a talk to spread the knowledge. So here I am after I don't know which would 3 years something. So here is the agenda. First, what is reactive programming? Second, why do modern front-end framework needs reactive programming? Third, we will compare how the reactivity works under the hood of the different frameworks that you might work with. And in the end, we will focus on Angular because recently they changed the inner way of how the reactivity work in the framework. So it will be interesting to see what they struggled with, the direction they choose, and why. I'm not here to advocate for Angular. This is just that it was the perfect example because they changed the inner reactivity. So first, what is reactive programming? Well, the notion was brought to the table by Paul Stowell not so many years ago, 2010. And Paul said in 2051, we will have this P-sharp language with the destiny operator that you can see here. So with the destiny, if A equals 10 and then B destiny A plus 1, then A will equals and yeah, if we put 20 into A, then we will have B equals 21, like out of magic. But is it truly 2051? I bet that even your parents used a tool with reactive programming inside. Even your grandparents, if you're young. Do you have an idea about a tool that everyone used that is based on reactive programming? Yeah, I think I heard it. So I will shut the sound. So yeah, this is Microsoft Multiplan. The demo that you can see on the screen, it's I think it's in 1984. So you might know the software with a different name that Multiplan. Multiplan was the first one. Of course, this is Excel. But what's interesting is that it wasn't Multiplan, the first one that implemented this. It was Lampart in 1969. And as you can see, so everyone knows it, like I can create inside a cell an operation saying that my cell, which one is it, 2, 6, is equals to 1, 6 plus 1, 7. And when I change one of the values, then the third cell automatically updates itself. But the problem is that JavaScript isn't reactive by default. If we try to do what Paul Stowell did with the destiny operator, but with 1 and 2 instead, because 10 and 1, it's too complicated math. If I create A2 being A0 plus A1, then I got 3, so this is legit. Otherwise, we would have an issue. But if I update A0, it's still 3. It doesn't update A2 by itself like magic. What I have to do if I want this to work is that I have to put the operation inside of the function, update function, and call it every time A0 or A1 is changing. Okay, so JavaScript is not reactive by default, but why do front-end framework need to be reactive? So if we open this little demo, I have a counter that I can increment. And when the counter increments, there is the isEven variable. Sorry, I might increase a bit. So here you can see better. But for me, it's not easy anymore. But so the isEven value is based on the counter, which is if it's even, it's true. If it's odd, it's false. And when I increment the counter, you can see that on the console it's working pretty well. The counter is updated. When it's true, isEven is true. When it's an odd value, then the isEven is false. But for my user, they don't see the update. The DOM is not refreshed. So this is an issue. And of course, we can solve it by like updating the DOM. So same example, but instead of just updating the value, then I will update the DOM. So it's working, obviously. But here, as you can see, so I call the DOM update whenever the counter value updates. I try to look at the node inside my HTML that are displaying the value, and I update them. I could also have done something more complicated, like, okay, those values are changed, they are displayed somewhere. You will trigger something that will refresh the DOM later. And this talk is all about that, the strategy of re-rendering the DOM. And in 2009, Angular.JS came in. But back in the days, it was really awesome, of course. Is there still people working with Angular.JS? Yeah, okay, one. I see less and less hands raising, but I think it was like in Toulouse or something, like half of the crowds raised the hands. I was like, oh my God. But yeah, that's not their fault. Like Google changed, one day to the other. It was like, okay, we are stopping this, and all company that invested a lot in this framework were like, what? So okay, with Angular.js, you can have this data binding between the HTML and the JavaScript with this scope, this scope operator, like this scope accessor, and then whenever a value that is displayed inside of a scope inside of the HTML change, the framework will notice it and will trigger a change detection. So obviously it's working. There is also this watch operator that triggers the change detection. So whenever there is a value changing inside the watch, the framework will run the digest loop and will re-render the DOM. The reactivity was not as optimized as inside Angular or other framework, but yeah, it worked, and it was really fine for application not trying to render too many data at the same time in the same screen. So how does that work? It works with the dirty checking process. So every time something change, you will mark it as dirty, so it will be in gray in the DOM. And the change detection strategy will go through the whole HTML tree. And when it will come to a node that is dirty, it will re-render it and go further to the DOM. Okay. So now, how about like the other modern framework that we use? So we will see that there is 3 different approach for reactivity inside frontend framework. The first one is the value-based. And I don't know if he is, I hope not in the room, because my stress will increase, but I don't know if Misko is at the conference this year. So he is the father of Angular.js, Angular Quick, and yeah, I know 2 years ago I went there, and he did a great talk on Quick. So I will take its advice, and with value-based, he said that if your system is relying on value-based, then you have to work with dirty checking process. This is the way. And value-based, it's like comparing 2 states every time, like the current one and the new one. And you want to spot the differences and update what changed. Angular is working on the value-based strategy. Is working. So if we open this little code in Angular, not the HTML, we don't care about that one, but the TypeScript. So this is the same example built with Angular. So for the easy event, we use the pipe that Angular developer might know of to avoid issues with performances. So this is basically Angular code. It's working, of course. But what is interesting is to see what is the result when it's compiled. So this is the compiled code. Obviously, you might not see every line, or you have very good vision. What is interesting is that here, I will help you, there is a template function with 2 arguments. The first one is RT, okay? The second one is CTX, I think for context. And we can see that if RF is 1, then there is some things that is done where I can see the element that I have inside my DOM and also like the hard-coded string. And if RF is 2, then I can see the CTX with the different variables that I created inside my TypeScript that are used there. So, okay, one template function that is doing something with nodes element. And how Angular is working is that when you trigger the change detection, then there is under the hood an enum that can have value either 1 or 2. And you compare the context with the state. Like the context is actually the state with the new values. And then you run several functions, and you end up with calling this template function with the RF. That is the creation of the element. And the value 2, that is the refreshing mode. And the context. So basically, there is a function that we render the DOM that is called by the change detection strategy. Okay, so what does call this change detection process? This is Node.js. And what is Node.js? Node.js is basically an execution context. If I open this stack blitz and I inspect for the console, where is it? Here. So this code is calling the function foo that is returning a new promise with a set timeout that call for after its resolution the bar function that throw an error. So we throw an error after promised resolution. And what you can see, or you might not be able to see it, now you can. Inside of the console, I can see my stack of error. I can see the throw error function that is wrapping up the new error throw. I can see the bar function up there, but after that, I cannot see the foo function because it's not in the same execution process. It's not in the same thread. And for the Angular team, that was an issue because they wanted to know whenever promise is resolved to call the change detection process because the DOM might have changed after that. So they created this zone.js script that will create a context and will bind the different threads, the one before and after the promise. So I think this is the stack now. So you can see that there is the throw error. Sorry, let me show you the script. This is basically the same one, but I do something weird with the zone to concatenate the two stack. So there is this throw error, there is the bar, and if I go to the bottom of the thing, there is the foo function there. So they succeed to do it. They combined the two stacks. So that was interesting to patch the promise. So they said, okay, let's patch basically everything. And they applied the zone script to every API. So whenever there is something happening that might need to re-render the DOM, they will call, the zone.js will see it and will call the change detection strategy and process. So the DOM refreshing, whenever there is like an event in some node of the DOM, then the change detection strategy will happen to the root node and will go to the bottom of the HTML. This is interesting, but sometimes you you might re-render things that didn't need it to be re-rendered. So they make the change detection strategy more performant with something that is called the change detection strategy on push. Who is using on push? Yeah. Okay. Who is not using on push? Then right after the talk, you can like put on push everywhere. You will increase your performances. And this will be really important for the signal change that is coming. So what changed with the on-push? With the on-push, you only update or check for if the component is dirty. If the input, one of the input change, there is an event that is triggered by a child of your component, or you change, you ask for the change detection calling the change detection ref detect changes, or the I think Angular.Ref.tick, something like that. So either there is an event, one input change, or an observable with the async pipe emits a new value. If there is no such thing, then the change detection strategy won't even look for the component, and you will improve your performances. So yeah, I really invite you to use onPush. The only thing is that if you don't change the references of your object when you let's imagine like you have an input, you pass an array to the input, and then you change the object that is in the second position of the array. It won't change the reference of the array, so the input won't see any difference. The change detection strategy on push won't see it, and you will end up with an issue. So if you work with onPush, you will probably have to work with like filter or maps, things like this that changes the reference of the object, or there is some library that does it also. So there is a little demo with this. So I wanted to show you the optimized way and the not optimized way. So I think this is the not optimized one. As you can see, so I want to get every time the this component is re-rendered for nothing, because it calls a function inside of the template that returns every time the same string. This is something that is considered as a back practice in Angular, because every time I increment the counter, oh, this is the optimized. Where is my change detection strategy on push? 35, you see it? Ah, yeah, here, okay. So, yeah, so this is the optimized way. As you can see, whenever I increment the counter, nothing happens on the console log. This one is only triggered once, one time when the component is mounted, and after that it's not anymore. But if I remove the onPush, and thank you for spotting it, you can see that just for the mounting of the component, it was called 4 times, and whenever I click on the increment, it calls it 2 times, because one time after the counter increase and after the is even recompilation. So that's why I'm suggesting you to put the onPush everywhere. Okay. So in Criteo, we have ESLint rules that might not be up to date at the moment, but it will be soon. So for now, if you're still working with the ng modules, you can use it, and we will make it standalone compatible soon. But you can also check for a few rules and take them. There is like if you're not using onPush, it will complain, things like this one. So I definitely encourage you to use it, or at least look for the rules and then try to implement it on your own. because you don't want your backend developer that do time-to-time front-end development to use component without the outpush, without the on-push strategy. Okay, React. So React is using, it's still a value-based strategy, but it's using this set state mechanism that will re-render the component and every child. So when you call for set state, you basically update all the child. So this is the working solution for the exact same example. Okay, this is fine. As you can see, the is-even is computed based on the counter. And even if there is a use memo and a use state under the hood, there is still this set state mechanism that is triggered. Okay, so yeah, that's nice, really working well. But let's put it with the same non-optimization as Angular, like with this console log that is triggered every time the title is refreshed. You can see as Angular without the on-push, every time the counter change, it redraw the header that doesn't need to be refreshed. And I have this console log. So yeah, this is not optimized, but like, is there something equivalent to the on-push? Yes, there is, because React is also amazing. It allows like the developer to basically do whatever he wants to improve the performance of its codes. And for that one, so I'm not a React developer, so I never know which should be true or false. But so you can call the React memo over your component. And you have the previous state and the next state, and you can decide whether it will be re-render or not. So you have the with Angular, you don't have the end with the logic. It's with the on push or without the on push. With React, you can implement whatever you want here to have it optimized the way you want. But if I put false, it will re-render it as the default behavior, and you will have this title change every time. So same for React. I think it's really known by the React developer, but yeah, use Memo to increase your performances. But there is, as I said, there is nothing coming out of the box, and that's why the big debate over Rich Harris, Ryan Carniato. So Rich said React is a terrible name for React because it's not reactive under the hood. We saw it. The equivalent of Zone.js for React is the developer itself. This is the developer calling for the set state or with the API use state and use memo. So yeah, so Rich Harris said that, and Ryan said, okay, if you really follow the definition of reactive programming, it's true that React doesn't apply to this definition. And if you go to the old documentation of React, I saw a paragraph where even the React team said, we know, we are aware. So this was the value-based approach. And what I want to say is that there is no value that is better than the other. Value-based really work well. The advantage of value-based is that it works. It works really well, and the model is really simple. Like you have two states, you compare them, and you work on this comparison. And it's really hard to fall off the reactivity cliff. So if I understand him correctly, I think he sees the reactivity as the chain of dominoes. And with dominoes, sometimes you have one that is falling and not triggering the second one. And I think it's basically falling off the reactivity cliff. There is an issue on your reactivity inside the framework. So as a user, you will see an issue, but for the framework developer inside the Meta team or the Google team, it will be really hard to fix. And with this model, this is really simple. However, when you want to improve the mechanism with the on-push, for example, then it's really easy to fall off the reactivity cliff. So I think they struggled a lot with that, with this implementation of the on-push. And also, you might have some performance issues. We saw it. There is a second way of doing reactivity inside of the framework. This is the observable-based. So, do you know what observable is? Yeah, raising hands. Sorry for waking you up. Okay, so I bet every people using Angular raise their hand because we do have the RxJS under the hood that is working with observable, but you don't need RxJS to work with observable. But to understand how it works, this is value over time. It's like when you subscribe to magazine and like every week there is a new magazine coming in your mailbox. Observables are that, but the issues with observable is that it's asynchronous, and for re-rendering the DOM, it's not ideal. We will come back to that later. So with the RxJS, the example of Paul Stowell with the Destiny operator, you can do it. It might be a bit more complex, but yeah, you can create reactive variables, and then with much of a complicated operator, then you can manage to have A2, which is also a reactive value that will, if you subscribe to A2, you will get this combined value. Okay, so there is a Svelte, I think it was version 2, not the latest one, that was working with like re-rendering its DOM with observable. And this is, so I can show you this as an example because this is interesting. From now, all examples will have this console log title refreshed. So the not optimized way. At least we will see if it's optimized or not out of the box. Let me clean all the things. Oh, it's installing. I thought I had it in cache. So, all right. Okay, title refreshed. It was called once during the mounting of the component. This is fine. And now, whenever I click, no more title refreshed. Okay, and this is out of the box. I didn't call to any complex change detection parameter or something. Nice. This is what we wanted to see. So there is this little dollar syntax that creates an observable under the hood. Okay. And what is really interesting is that there is this invalidate function that kind of act like the template function that we saw with the previous example of Angular. It marked the component as dirty, and with the mark dirty, we can see that there is it's schedule an update, and when the update is happening, then it will remove the dirty. So this is the slide. After that, schedule another update, and then after that, like you call for the p function, and then you remove the dirty. Okay, so what is this p function? Oh, I thought I had, yeah, okay, I had this. No, not that one. Somewhere I have a compiler link. Is it this one? Yeah, okay. Okay, so I remember what I had to do. like I have to call for this inside of this, but I think I have to remove the TypeScript. No, it's not using TypeScript, so this is fine. So I don't know if you will be able to see it, but so this is the compiled JavaScript of my script. And I can see a function, create fragments, that is, again, like Angular, taking all my elements with the main, the h1, the span. I can see the counter, thing like this. I still have this context variable, and they even applied the same name, like the CTX. And if I go to the P function, you can see that there is this set data that will apply the counter new value to the right element inside my DOM. So basically, I invite you, so the slides are public, I invite you to dive deep to every example and see this, but it will spot the node where the variables are used. And with the observable approach, it will update the right node of the HTML based on value that changed. So this is really interesting. The issue with the observable based is that it's asynchronous, and it's not really easy to handle DOM refreshing with asynchronous mechanism. You prefer to have something synchronous, like my data updated. I want my DOM to be refreshed right away. I don't want to wait for something that will happen and one day I will have my DOM refreshed. No, I want something synchronous. So it might not be the perfect way to do it, but it works. And also the biggest cons with observable. So people that are using React.JS there, it took you 1 year to understand how it worked or something like this. Yeah, 2 years. So this is the often when I talk to someone and say, what do you don't like with Angular? They said, all the observables. And it's not really Angular, it's React.JS, but okay, I feel you. This is really really complicated to understand, but once you understand it, this is really wonderful. But yeah, you have to subscribe to it to get the value, and more importantly, you have to don't forget to unsubscribe. Otherwise, it will continue to push values even if your component is destroyed, and you will have some weird behavior. So yeah, and yeah, you will have performance leaking. So okay, observables are great, but you have to understand them, which is not easy. And so there is another way. The other way is the signal-based approach. Again, I'm not here to say that signals will replace observable, because observable are asynchronous, signals are synchronous. So there is still some things that you want to keep doing in the asynchronous way, and the observables are a really nice way to do it. But if you want to work with synchronous data, reactive synchronous data, then signals are really with a better developer experience. So Misko said, okay, signals are like observables, but synchronous, and you don't need to subscribe and subscribe it. It's more complicated than that, but yeah, basically this is how you can see it. The first framework that we will look for is Vue. That is, so they re-implemented the logic of the signal. See, the signal was put inside the frontend framework by Solid, but I think the JS library that was providing this signal API first was something that existed way before. I don't recall the name, but this is also interesting to see. And I think inside the link that I put in the slide, you can retrieve all the source code. Vue.js is using two things, the proxies or getter and setter to build reactive objects. Basically, if you create a reference, a ref, so a reactive object, when you call for the value, it will, of course, give you the value, but first it will track, like, okay, you want the value, but I want to know who you are, and I will take your reference and put it somewhere in my memory, because whenever the value will change, I want to inform you that it changed. And whenever you set a new value, then it will trigger something that will inform all the tracked reference that the value changed. And whenever you can see this documentation, this code and explanation inside the Reactivity in depth in the Vue.js page. You can see basically a simplification of the track function and the trigger function. Everything is stored inside of, so I think it's hmap of map or something like this. So basically, you store the okay, who needed this variable, and you can apply the effect whenever the value changed. And with that, you have something reactive, because you might be able to do something like this. So I create a ref for A0, another one for A1, another one for A2, and then I can so have this watch effect over to watch every change of the A0 and A1 to update A2. But there is this declarative way that is more convenient, and which is A2 is a computed of A0 value and A1 value. And with that, you achieve to have Paul Stowell Destiny operator, and it's synchronous. And what Evan you says inside the doc is that, so it's not how it works for Vue, but you can imagine re-render your HTML node based on this watch effect. Like you look for a change of the count value, and then you update the span or the paragraph HTML tag content whenever this value change. But it's a bit more complicated than that under the hood. But yeah, basically this is the philosophy. And so I won't open the example, but you can trust me, or I will do it, but I will skip, due to the time, I will skip the solid demo. But as you can see, there is still this this conference call that, oh, but I don't have the, where is the console log? Okay, so yeah, it changed because whenever this is called, of course it will be optimized because I don't have the console log at the right place. But yeah, you can like trust me if I do something like this, return. And here I have the console log called. Okay, I have it once, but whenever I click on the increment, it's not triggered several times, so I'm optimized by default. This is nice, and for Solid, it's basically the same approach. So, but it's using GSX. But yeah, you can run this demo. You can see that the conference call is only called once, and there is a playground like for the Svelte. You can look at this code compiled. It's much more complicated to understand where is the different things, like the P function or the template function, but it's there. So, okay, signals. This is really performant out of the box, and there is a really good fit for the template because this is synchronous. But as the cons, there is an API and you have to stick to it. and I think they can add this with effect. It might be complicated to understand for the user of your framework how to use the effect and where and how. Okay, so with the last 5 minutes, I will focus on Angular to explain how they try to ditch Zone.js to go to the signal. So remember, inside Angular we have this Zone.js that is spying for every API that might change the DOM, and they re-trigger this change detection strategy. But they wanted to change that because Matteo, which is one of the main contributors to Node, he said that whenever you monkey patch an API, like the Zone.js did, if there is an issue, it's on your own. Like you did that, you're responsible for it. And the Google team, when they created Zone, they were much aware of that. So at a certain point, it reached the limit, and they wanted to go out of Zone.js and using another strategy for the reactivity. So they did RFC that is now closed, but there was this really big discussion where anyone could participate. And they said, okay, we need something to improve the reactivity of Angular. They defined the different rules, and they said, okay, we're considering improving Zone.js because it's there, and maybe we can improving it, and it will work better. We can have this set state style API, so we can do like React, we can do like Solid and Vue. We can do with React.JS because with observables we saw that we are able to update the DOM, and we can also create a compiler like Svelte did to handle reactivity by cheating a bit JavaScript or proxies like Vue again. And so why not React.JS? Because it was already there. With React.js, sometimes you might have the right value in the end, but between an update, you might have one glitch, one value that is not the final update. And you don't want that. So React.js was not the good fit. Obviously, there is a way to optimize this code to not have this one, but it was complicated. And again, React.js is asynchronous, and they wanted a synchronous way to update the DOM. So they re-implemented this signal API, like Vue did, but in a different way. So you can create a signal, you can update the value. I think update was removed after much discussion, but you can set. No, update is still there. I'm a bit confused. But anyway, you have this. You have this API to create a signal to set the new value, and by accessing the value, you will need to call for the counter with the parenthesis, not the dot value. And like this, like this, you are able to have like the Paul Stowell example with the destiny operator again. And what's is great is that if the color is based on the is even, that is a computed value, then if is even didn't change, the computed of color won't be recomputed. So this is really nice for the performances. Last minute, I will go to the last slide, which is the next step for Angular. Inside Angular, you can already, since version 19, but with 18 it was possible with something less nice than this beautiful expression, but you could already, or you can, since version 19, say, okay, I don't want to use this on JS. I want to use the still this global change detection strategy, but which is triggered by the signal change instead, not the zone.js. And this will be the future of Angular, so you can try it, maybe not push it straight away to production, but at least try it to see if you need to rework your whole code to have it working or not. And time's up. The things that will come after that will be the component signal that will see which node, or at least which view inside the node was updated, and will update just this node instead of calling the global change detection strategy and go through the whole template. All right. Thank you. That was really great to have you there. You can see me to ask questions since the time's up. I will be just there answering your question, and I think I will just take one selfie with you people. So time to raise your hand. Yay! Thank you. Have a great day.
All systems are nominal. Initialize Genesis.